this. It doesn't need to be super precise. You just need to have the basic shapes of the graph. All right, cosine, we need the first quadrant, and the first quadrant are these values right here, with this being pi over 2. But we're going to include the second quadrant from the unit circle, and that's these values. And I'll show you what I mean from the unit circle. Notice the first quadrant is still good old right triangle trig from geometry, and cosine deals with the x values on the unit circle. It doesn't repeat when we go into the second quadrant. That means these are new values, and that's like saying that it passes the vertical line test from the first to second quadrants. But once we get into the third quadrant, these values are a repetition of the second quadrant for the x values. So these are not included, nor are these. That means the range for arc cosine, let me go ahead and write out arc cosine. So this is f of x. I have cosine inverse 1. The range for this needs to be restricted from 0 to pi. And that is because it needs to pass the vertical line test. All right, and now let's just talk about inverse tan or arctan. And let me get this. All right, this is a little bit confusing, so let me see if I can help you understand what is going on here. Looks like an interesting grid. Now the purple is the original graph, so I'm going to go ahead and select that. Negative pi over 2 to pi over 2 is the first one. So let me go ahead and restrict the domain on this so it won't look quite so confusing. That's a little bit better. All right, so negative pi over 2 to pi over 2 is the asymptotes. If that's reflected about the line y equals x, this maroon graph becomes the new functional graph. Go ahead and draw what you see. All right, so the original asymptotes occurred at negative pi over 2 and pi over 2. When I reflect this about the line y equals x, I get two new horizontal asymptotes, but all we need to see is that tan cannot be bigger than pi over 2, nor can it be less than negative pi over 2. So I'm just showing it from the graph, but f of x has a restricted range of negative pi over 2 to pi over 2. But in this case, it does not actually ever get there because it is an asymptote, whereas the arc cosine did get to 0 and pi, and arc sine did get to negative pi over 2 to pi over 2. Let me say just a few more things about functions to make sure that you're remembering things as we're talking about this. Remember, an inverse function is defined as being able to undo the function. So the inverse function undoes the sine function. That's like saying what angle goes with this sine ratio. In this case, it would be x. So another way we write that is if we think about it from a geometric perspective, we say arc sine of x would be x. And just want to re-illustrate or restate what's going on here. Notice there are an infinite number of angles that have this, so we need to restrict this angle in some way so that we can get these x values. Awesome. Let me dive into just a few problems to make sure that you're understanding how to illustrate these concepts. I'm going to pick some of the even problems from the textbook, and I've got them pulled up here. Let me get that off. You've got to do the odds. I'm going to do some of the evens. So I'm going to write it out on paper. Just follow along as I go. Write these in your notes. So number 2. Number 2 says we need to find the arc sine of 0. Arc sine of 0 is, this is what I do. It's asking for the angle that goes with sine of 0, remembering that the range of arc sine is the first and the fourth quadrants. So the sine value that has 0 on the unit circle, well, sine is the y value on the unit circle. So that is this coordinate right here, which means the angle is 0. Now you're supposed to do this without a calculator, but I would like for you to check your work as you're going along. This needs to be in radian mode because it doesn't tell you to be in degree. So I'm going to be in radian mode. And I'm going to press second sine 0, and I get 0. Reason it out the way I did, and then go ahead and write out your values. Let me do a couple more with this just to make sure you're following along. Let's say we're looking for number 8, which is inverse sine or arc sine of negative square root of 2 over 2. Remembering that the range of arc sine, just like I illustrated before, is negative pi over 2 to pi over 2. Sine is the y value on the unit circle. That means we need to be in the fourth quadrant if this is negative. Negative square root of 2 over 2 is that value right there, so this is negative pi over 4. Like I said, it's helpful when first learning this to check out your work with your calculator. So let's do negative square root of 2 divided by 2. We're going to get this value. Let's see how this relates to negative pi over 4. Hey, what do you know? They're the same. Let's do one of the tan ones because I find that a lot of students are confused with it. Number 9. Actually, sorry, this is number 10. That's what I chose. Number 10, we have arctan of the square root of 3. Now, tangent, as I showed from the graph, is confined to the first and fourth quadrants. So if we're looking for a square root of 3, the only quadrants we have, the coordinates we have from the unit circle are square root of 3 over 2, 1/2, or 1/2 square root of 3 over 2. And we have the positive and negatives, or negative y values in the fourth quadrant, excuse me. If this is positive, that means we're in the first quadrant. So we're either this coordinate or this coordinate. Tan is defined as y divided by x on the unit circle. Well, this divided by this is not square root of 3. In fact, this one divided by this is. 1/2 is the x value. Square root of 3 over 2 is the y value. That means we're at this coordinate, which is pi over 3. And like I said before, make sure you check out your work by plugging this into the calculator. But this is a non-calculated portion, so do it first without a calculator. Second tan, square root of 3. Let's compare this to pi divided by 3. Hey, what do you know? They're the same. Now, there's some problems that ask you to do it with the calculator. I'm just going to illustrate these right here, what to do with the graph. I'm going to talk about 36, and you need to do 37. So we're saying what angle goes with cosine of x. So what angle? This is the angle that goes with this cosine. Well, in the unit circle, we're looking for pi over 6. So pi over 6 has an x-coordinate of square root of 3 over 2. If we're looking for what angle goes with cosine of negative 1/2, remembering that cosine is defined or restricted to 0 and pi for the range, it has a negative 1/2. Negative 1/2 is right here, and that is 2 pi over 3. So this has an angle of 2 pi over 3. And then negative 1 is this coordinate right here, and that's pi as your angle. Awesome. Go ahead and draw number 38. We're looking for the inverse function, write theta as a function of x. Well, theta of x is, now what I do is I set up the trig function cosine theta is equal to the adjacent over the hypotenuse. And if I were solving for theta, then I would get cosine inverse of 4 over x is my theta. This is just theta of x equal to that. All right, for number 44, it says use the properties of inverse trig functions to evaluate the expression. Tan of arctan, 25. Now the trick here is making sure that we're in our domains and ranges line up. So 44, we have tan, arctan, 25. Now the domain of tan is actually negative infinity to infinity. As you saw that this graph went off to infinity like this, which means that this domain fits within this right here. And then the output is actually regardless. In fact, since this fits in the domain, we can use these and these cancel out and we got 25. All right, let me do one of the ones from 49 through 58. It says find the exact value of the expression. I'm going to do this by sketching a triangle. This is secant of arc sine. Now this looks crazy, but if we reason it out with the triangle, you'll find that it's not that big a deal. This is saying what's the secant of the angle that has a sine of 4/5. So if I just draw out a triangle and do the sine of 4/5, calling this theta, I don't need to find theta because I'm looking for secant. Secant is the hypotenuse over the adjacent, so I need to do the Pythagorean theorem, which is 25 minus 16. 25 minus 16 is 9. I should have done this with a triple. That would have been faster. So this is simply 3, and the secant of this triangle is 5 divided by 3. Notice I didn't need to find that angle. That's irrelevant. It's the secant of the angle that has sine of 4 over 5. Let me do the ones with the algebra, like number 62. Let's pick that one. Secant of the arctan of 3x. We do not have to draw this to scale. We can just draw out some triangle, theta, 3x. Now this can always be written over 1. And we're looking for secant, which is the hypotenuse over the adjacent. Hypotenuse over adjacent is 1 squared minus 3x squared, which is 9x squared, square root all. And secant is this divided by this. So it's 1 divided by the square root of 1 minus 9x squared. But I hear from your calculus teachers that you do not need to rationalize the denominator, so we can leave it like that. Alrighty. I think that's it for the video. Go ahead and make sure you take these notes. Come back next time.